Assalamualaikum and hi, we are from Group 1, consists of 5 members, which are Camilia, Nurul Najiha, Nuri Faiza, and Muhammad Hazib will be presenting our case study with the title of Design and Optimizations of a Sensitive Analytical Spectrophotometric Method for Microdeterminations of Copper 2 from E-waste by using of a novel chromogenic extract tank. My name is Nura Adila and I will explain about the copper ion. Let's move on to the introductions. What is copper? Copper is the 25th most prevalent element in the crust of the Earth. So the third most crucial trace element for human nutrition is copper ion. The World Organization WHO prescribed daily intakes of copper at only 0.5 mg and 2.0 mg per liter in beverage. A person who consumes too much of copper will get Wilson's illness, jaundice, and liver damage. Anemia and clearly has side effects of deficiency in copper. Looks for the uses of copper, melanin for skin pigmentations and several body functions such as hemocyanin, fungicides, insecticide, micronutrients in the fertilizer. Copper is also used in the manufacture of wire, coins, and medical products. So copper can conduct electricity and heat well. Also, it is used in the manufacture of fine wire, semiconductor, and computer bar.
Let's move to the methodology. For the pre-experiment setup, on a 400 MHz wavelength spectrometer, measurement of a synthetic ligand were conducted. We used a 1 cm quartz cell and Equiptronic EQ822A UV-VIS digital spectrometer to measure the absorption of the extractant ligand and its copper complex. The EQ614A model of the digital pH meter from Equiptronics was used to measure the pH levels. 1 mg copper solution was made by dissolving 3.93 gram of cupric sulfate pentahydride in 1 liter of water containing 1 cm cubic of concentrated sulfuric acid and standardizing by tertiary technique. Water that has been deionized and twice distilled was used in all of the tests. The potassium dichromate solution was used to clean all the glass containers and equipment, and this was followed by washing with soapy water and rinsing with distilled water. Next, synthesis of chromogenic extractant. First, methyl oxide combined with ammonium thiocyanate in sulfuric acid in water for 50 minutes to get 2-methyl-2-isothiocyanato 4-pentanone. Second, 2-methyl-2-isothiocyanato 4-pentanone was refluxed with 2-aminopyridine in 50 ml ethanol for 50 minutes to get PTPT or synthesis of 1-pyrimidine 4,6-trimethyl 1,4-dihydropyrimidine 2-thiol. PTPT was recrystallized from glacial acetic acid, washed with water, air-dried, and analyzed. PTPT was dissolved in 50 cm cubic of carbon tetrachloride to make a 0.01 mol stock solution. Next, recommended procedure. In a 25 ml calibrated beaker, have taken 10 micrograms milliliter -1 of copper sample solution and pH of solution was attuned at 9.0 by using dilute hydrochloric acid and sodium hydroxide solution. Sample solution was transferred to a 125 cm cubic separatory funnel and treated with 0.01 mol liter -1 PTPT and 0.1 mol liter -1 synergen pyridine in carbon tetrachloride. The organic and aqueous phase were separated by shaking the separating funnel by hand for 10 minutes in a steady rhythm. The copper ion from the aqueous phase moved into the organic phase with the extractant because it formed a complex with the extractant. The organic phase became green CHM2 and was transferred to a 25 ml beaker containing 2.0 gram of anhydrous sodium sulfide to remove water, and it will be transferred to a 10 cm cubic flask. The organic complex absorbance was measured at lambda max 615 Newton meter against a yellow black. Using the same method, the unknown amount of copper was figured out by plotting the Beer graph in a similar way. Below, it shows the three equations for this procedure. Next, this part shows scheme 1, which is synthesis of 1-pyrimidine for 4,6-trimethyl 1, 4-dihydropyrimidine-2-thiol, PTBT, and scheme 2, which is extraction of copper with PTBT extraction and development of green color copper, PTBT-PY complex.
The results from the journal. So as you can see at the table 5, we have a result for the determination of copper from artificial synthetic mixtures. So the developed method was validated by applying the proposed analytical procedure on artificial synthetic mixtures as mentioned in the methodology. So next one is table 6, which is the result for determination of copper from alloys. So as you can see here at the amount of copper found, the proposed method the result from the proposed method is similar to the AAS method. So this determined that the proposed method is suitable. Last but not least, the result for the determination of copper from e-waste samples. You look at the table 7. The e-waste sample were collected from different areas of Kolhapur city in India, and plastic cables, wires, and glass have been removed from the sample, and then they were cut into smaller pieces to dissolve it, to prepare a thick solution containing metal ions. So look at the results of the amount of copper found. In the result, we can see that the proposed method is also similar to AS method. So this means that proposed method is suitable for us to use.
So, my name is Hati. Right now, I will present to you about the discussion of the analysis journal CHARADE. So, the spectral characteristics. So, as an example, the absorption spectra of a yellow color PTPT extractant pyridate at its copper complex were deliberate over the wavelength range to 300 and 1700 nanometers. So, and the next point is effect of pH on the extraction systems. So the extraction system on this point is plainly extract the copper from the organic phase. So the effect of pH is can be determined by calculating the value of comparative figure and extraction deficiency distribution. So let's assume that we go to the value of comparative figure. So comparative figure we can assume value of pH as comparative figure. Such example, if pH 8.0 of aqueous solutions, uh, absorbance of the color complex was originated low. So originated low, and in the aqueous solution of pH 9.7, the absorbance of the produced color complex was reduced drastically. So that's the second point. The third point here is effect of concentration on chromogenic extractant. So the PTPT or chromogenic extractant are useful chemical ligand that has been revealed as formation of color to determine the product, such as it was found that 4.0 ml of 0.01 mol-liter PTPT was essential for full and constant color development in the presence of 5.0 ml full and constant color development. In absence of pyridine, absorbance was reduced. And then next point is influence of equilibrium parameter. So equilibrium parameter is component that balance the value of process and in order to maximize the real product. So when we talk about influence of equilibrium parameter is to optimize the time of main process, such as determination of spectrophotometer of copper 2.
Assalamualaikum warahmatullahi wabarakatuh. My name is Kamila Minti Abdul Aziz and I will conduct about the conclusion part. So the conclusion based on this study, a novel 1-pyrimidine 4,6-trimethyl-1, 4-dihydropyrimidine 2-thiol PTPT extractant was synthesized. 1,20,40-dinitrophenol 4,6-trimethyl-1, 4-dihydropyrimidine 2-thiol has been categorized as a ligand sister. This ligand, as synthesis, was used to determine the extractive spectrophotometry of copper-2 and prove its sensitivity and selectivity to copper-2. This method is very easy to use and boot, and it also reliable. This method has the advantage of less interference ion, and it can be an alternative to instrumental technique that can be used for the determination of copper-2 from real sample or e-waste. Several important features has been introduced for the analysis of copper-2 from e-waste. First, the recommended extraction procedure is a single stage. Second, low ligand concentration. Third, PT-PT form complex with copper-2 in weak basic medium. Dilute concentration of pyridine is used as a cyanogen. Stoichiometry of extracted species is 1 to 2 and it has been effectively proved by well-known methods. 6 is the ternary complex is stable for more than 3 hours. And lastly, the developed method is reliable applied for the determination of copper-2 from e-waste. These are 7 important features that propose to be followed to analyze copper-2 from e-waste. So that's all from our group and thank you.